You may notice that something is missing. There used to be a giant pinball machine right here, and it's not here anymore. It's actually on its way up to Pittsburgh to my brother, and he has a pretty epic collection of machines going on already. He's got an Aladdin's Castle, a Captain Fantastic, a Pennant Fever, and a Kicks soccer machine. And I think the Spanish Eyes that was here is gonna make a perfect addition to his collection. But getting the Spanish Eyes out of here was kind of the first step in some changes that need to happen in the room here. This room is big, make no mistake. It's 25 feet by 11 feet, so it's a pretty substantially sized room, but it's not infinitely big, so there's limited floor space here, and I gotta keep a lot of room open in the middle to move things around and work on things. So I'm really limited in the space that I have against the walls here, and well, there's new stuff coming, which means that I need to make space for the new stuff that I really want to work on. And there's some stuff in here that I haven't touched in months, and that stuff needs to either go into storage or maybe even go to a new home. So getting the Spanish Eyes out of here was kind of the first step towards that. But that means that we opened up a little bit of floor space for me to bring something else in that I really want to work on. And that is this thing right here. This is a Texas Instruments Omni 800, and they say 810 RO terminal here, but essentially it's a serial printer that uses 14-inch wide green bar tractor feed paper. But I've been on the hunt for one of these for a long time, and that's because this was also a printer that Centurion rebadged and sold with Centurion systems like the little one over here. So like an early CPU 5 system would have absolutely had this printer in it. As a matter of fact, the desk system Centurion that is up at Butler Tech came with this exact same printer. The only difference is that this part that's painted black on this one is painted blue on the Centurion branded ones. So that's why I've been on the hunt for one of these. I want a printer that I can plug into my mini Centurion here and take this whole package deal to events so people can get hands-on with essentially a complete system. Now, I've been on the hunt for one of these, and they're actually quite hard to find, but Boxcar Jim came in clutch here. And you might remember him because he also hooked me up with the absolutely adorable Texas Instruments data terminal that we have over there. So, Boxcar Jim, thank you so much. I'm really excited about this printer, and it looks to be in fantastic shape. I don't think it's going to take much work to get this thing up and going. I do want to paint this panel blue though. So we're going to pull this panel off, and I think we're going to need to clean up some grossness of sound deadening on the inside. And then we're just going to give the whole thing a clean, take a look at the inside, put it all back together, throw some paper at it, and get it printing off of our mini Centurion over here. This is pretty exciting. I've been looking for one of these for a while, so I'm excited about this one. This thing is already in really excellent shape. The only problem is the sound deadening on the inside here. Both on the underside of this top plastic cover and all along the inside here, the sound deadening is just coming apart. It is absolutely disgusting. I will take off these stickers up top here and save them because they're in really excellent shape. But while we've got it open here, let's flip the power switch, see what happens. Actually, I already know that it powers up. I've done this before off camera. There we go. We saw the head move. We do get an error up here, but you can clear it by hitting the reset button. But we're powered up now. That's good. The head moved back and forth a little bit. I think that is excellent news for getting this thing up and going. We just got to get it clean first. Let's get this thing apart so we can see what we're working with. There are 2 screws on the back, but unfortunately one of them is broken. I'll have to glue that together later. Once you lift the lid up, there are 3 more screws hiding out under here. With all 5 screws removed, the cover lifts straight up and off. Next, let's get that big aluminum cover off. There are 3 screws holding it in place, 2 on the sides and 1 on the back. Then it just slides straight up and off as well, revealing a trio of PCBs that make up the logic of the printer. Let's go ahead and get those PCBs out, partly so I can clean everything, but mostly because I just want to look at them. Fortunately, they slide out nice and easy. Next, let's remove as much of the old sound deadening foam as we can. This stuff has completely separated and is brittle and awful. And I've spent so much time with this type of really old sound deadening, I can't even visualize how this stuff looked new when it wasn't a brittle nightmare. With all the stuff out though, let's blow out the printer case. A little compressed air goes a long ways here. You can see a hilarious collection of carcinogens and bad decisions flying out of this thing. Moving over to the top cover, let's carefully remove these stickers. I'm going to save these, clean them up, and eventually re-stick them back in place. The sound deadening foam under here though needs to go. Fortunately, a scraper makes quick work of it. Then it's out to the hose to give the thing a really good wash. And after drying, more cleaning and wiping down with wax and grease remover, let's spray some primer gray onto it. I was almost out of paint, so it's not the most even coverage, but after letting it flash dry for about 20 minutes, I pulled out the spray gun, loaded with some Centurion blue, and laid down some fresh paint. Ultimately, I put about 5 coats on, and while it wasn't my best paint job, I got a run here and there, it came out all right, I think. Before we put our freshly painted top back on, let's take a look at the 3 PCBs that came out of the printer. Starting here at the bottom, this is obviously the power supply. I mean, aside from the fact that it says power supply on it, it very clearly looks like it has a bunch of electrolytic capacitors on it, but these are all made by manufacturers that are pretty high quality, Sprague and Mallory. So I'm going to work under the assumption that these are good, especially because we powered it up once and it looked fine. But there are a bunch of test points right here along the top for plus 12, minus 12, plus 8, minus 75, minus 5, plus 30, and plus 5. I'll go through and check all of those once we get this board plugged back in. Right above it, we have the driver board. And we can tell that because it's got these driver transistors with big old heat sinks on them. And honestly, it doesn't even look that complex. It seems much simpler than the driver board that's in the ODEC Data 100 printer that I have over there, which makes sense because that thing has 66 hammers, whereas this is just a simple dot matrix. So we only need enough drivers to drive the dots in the matrix. So it looks pretty good. Right above it is the main processor board. We have an AMD version of the 8080. We have a TMS 5501, which is an I/O controller, and then we have some AEM 9101 static RAMs over here. And I'm pretty sure that these two guys here are ROMs. So it looks good, except for the obvious, there's a battery right here, and I can see that there is some nasty leakage around it. So I need to get that battery out of here, try to clean up this leakage and see if there's any broken traces. Fortunately, getting the battery off is pretty easy. It's got a pretty interesting construction with this little plate that hinges and then screws down over the top of the battery, making connection. I soaked the area in IPA and I scrubbed it really good with a toothbrush, and then I went through with an X-Acto blade and tried to scrape away as much of the crustiness as possible, and then went back over it again with IPA and a toothbrush before blowing it dry. And then I sat down with the multimeter and I tried to beep out all of the traces I could see, and they all seemed to be okay. However, it didn't fix it. We still have problems. So if I flip it on here, it's gonna beep really loudly. There we go. So it beeped 5 times. Sorry, that's crazy loud. It beeped 5 times and our error light is continuing to blink. But we saw the carriage here move slightly. And I don't think this is a problem from not having a battery. If I look in the manual here, I can see on the schematic that that battery is just for the 5101 option here. And actually, if we check in the manual, we can see exactly what is causing our problem. It says the error indicator has 2 functions. For a parity error, indicator lights steady when a parity error is detected. Wonderful English there. For a print head carriage fault, indicator blinks if the print head carriage runs into an obstacle or if the microprocessor loses tachometer pulses for any reason. The audible tone beeps 5 times. And that's exactly what we're seeing. This is flashing and the audible tone blinked 5 times. But we can see that this is moving and I can push it around and it moves totally fine. So it's not a physical problem. That means that I think we're losing the tachometer signal between the controller motor here and the PCB back here. And that could be any number of faults. And if we look at the schematic for the encoder, there's 4 LEDs and 4 photo transistors, and then there's an LM339 which has 4 op amps on it. And so as this carriage moves back and forth, it should be moving a the chopper essentially that is either making or breaking the light coming from the LEDs to the transistors. And with it powered up, it was kind of a nightmare to try and test all of that. So I've unplugged it here and I figured out the pin out, and I've got plus 5 volts and ground plugged into it, and then I've got my scope hooked up to just one of the pins here. And I should be able to turn my bench power supply on here, have 5 volts going into it, and then move this back and forth, which is going to be moving the chopper inside of the encoder, and we should be able to see a pulse or something coming out of there. And so I've already tried this, but if we turn it on, this doesn't appear to be pulling any current at all, but I wouldn't expect it to pull much. And we can see that we've got some noise on the scope here. I don't really know what that's about, but if I move this around, I got absolutely nothing at all. Now what's interesting is if I go through and I change this and I check every single plug, they're all identical. So either all 4 LEDs have died, all 4 phototransistors have died, or our single LM339 has died. Or at least that's my current thinking. So I'm gonna try and see if I can get it apart and get to it. I've got it out and on the bench here, and it was an absolute battle to get this thing out. I had to unwind the cable that is moving the carriage back and forth. I'm not entirely sure I'll be able to get this back together correctly, but we're here, we're in it, we're committed. Let's get to it. This is our LM339 here. Here's the plug where the ribbon cable plugged in. We've got some potentiometers over here for correction. The LEDs are on the back side, and I can see a huge amount of corrosion right underneath this plug here. So that could very well be our problem. So I'm gonna remove this kind of like rubber pad here that's supposed to seal this whole area off, and take a look under there and see if we have any broken traces. Maybe we can get out of this with a simple fix. If not, it looks like we can pull this whole PCB off with just 3 screws here. So I should be able to pull the PCB off and take a look at the underside, or I might be able to power it up, spin it around, and check the inputs to the LM339 and see if our phototransistors are good. I get why this foam exists, but this stuff always just captures moisture. To get it off, I slowly worked it back and forth with my X-Acto knife, and thankfully it slid off without too much drama. I tried to get a good photo of just how nasty it was underneath. Foam mixed with adhesive, mixed with moisture, and it's just disgusting under there. I soaked the area in IPA and scrubbed like crazy. Then I went back at it with the X-Acto blade and carefully removed as much adhesive and grossness as I could. And after several rounds of IPA and then mechanical cleaning, it's starting to look pretty good. Thankfully, all the traces are completely intact and measure out just fine. Looking around for other obvious faults, this flex cable that goes from the PCB to the LEDs beneath the encoder wheel looks like it's in a right proper state though. Well, the problem was definitely corrosion, but not in the place I thought it would be. The connector up top, all the traces to and from that look fine. Everything beeps out okay. But the LEDs are sitting underneath here, and they have a little flexible cable that goes to them, and it is completely corroded through. All 3 lines are completely broken. And that means that the LEDs are never going to get any power, which means they're never going to create any light, and the phototransistors can never detect that. So there's our fault. Now we just got to try and figure out how to fix this nightmare. We're going to turn into a bit of a slideshow for a minute here, simply because it's all just so impossibly small and hard to film. But you can see here, after desoldering the cable from the PCB, I was able to remove it fully, and our good friend foam here has ruined us yet again. It took some work, but eventually I got the foam removed, and in order to get the LEDs out fully, the flexible cable came all apart, which wasn't surprising given how gross it was. Fortunately, in the manual, they have an image of how the flexible cable was originally wired up. Now I just need to recreate this using nice solid core wire. And while it was a fiddly nightmare that took me well over an hour, I think this will work perfectly. Ultimately, I potted all this in hot glue to hold it in place, but I forgot to snag a picture of that, sadly. All back together with my bodged wires going on, so let's see if this thing is actually outputting encoding signals. So we'll go ahead and flip power on here. We're actually drawing some current now, 0.02 amps. We weren't doing that before, so that tells me that the LEDs are probably on. Let's give it a spin here. Look at that. We are encoding data. When I spin it, we get all sorts of little stuff. That is excellent. I think this thing is working now. I think we can put it back into the machine and try to get that printer up and running. All right, moment of truth here. We want to see this error light not come on. The paper out light, I don't know, maybe should come on, should not come on. I don't know what the startup procedure of this thing looks like, but let's find out. Fingers crossed. It's so loud. So the paper out light did come on, but it looks like it got the carriage all the way to home. That's fantastic. I mean, the carriage seems to be working now. We have repaired the encoder on that. And I think the paper feed is also working fine as well. I can move that bit just fine. I think we need to put some paper in it and hook it up to something and see if we can get something to print. This is exciting. These buttons here were interesting. There's normal and then test. And I think if I push test and I hit online here, and there it goes, there it goes. The ribbon is super dim at the moment and a little misaligned here. It's getting darker and darker, so I think we're getting to a better part of the ribbon, but it is printing a full-on test pattern. So that is good. I mean, it's crazy loud, but that is excellent news. Oh man, look at that. That is awesome. Okay, making a little more progress, and I'm trying to get it to print. The quick brown fox jumps over the lazy dog, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. And well, you can see we got some issues. So let's tell it to print here again. Yeah, I mean, at least it's consistently bad. We're pretty close. So it's like we're losing a bit somewhere, but the test pattern printed fine. So I don't really know what's going on. I'm gonna have to get in deep. Let's start with the low-hanging fruit here. There's a lot of socketed ICs, and it'd be a good idea to remove each one, inspect the sockets, coat them in deoxit, and then reseat all of the ICs. And look at that, right out of the gate. The RAM socket that was closest to the battery has 2 pins that are just pooched. It looks like they corroded and then collapsed. That could definitely be causing our stuck or missing bit. I desoldered the socket as best as I could, but the combination of battery leakage and just an awful socket meant that it didn't come out gracefully. It didn't lift any pads or traces though, so that's good. I soaked the entire area in IPA, gave it a solid scrub, then went back over all the traces with the X-Acto blade to clean them up, and they came out all right, I think. I beeped out every trace, and they are all still making good connection. So I think it's time to solder in a new socket, and then finally soak all the remaining sockets in deoxit and pop all the chips back into place. Was that bad socket the last of our problems, or do we still have a whole lot more nightmares lurking in the shadows? Only really one way to find out. Let's flip the switch. Hopefully we don't let out any magic smoke. We'll put the machine online. And let's try sending some data. Oh, that fixed it. The quick brown fox jumps over the lazy dog. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. That did it. Ha ha! That was an epic, epic win. All right, time for the final boss. Can we get the mini Centurion, the computer that I ultimately want to use with this printer, to play nicely with it? I've got the printer on and plugged in and online, and I made a custom cable that goes from the printer to the Centurion. And the Centurion itself is running an operating system that originally came from Butler Tech. And that desk system also had a TI-810 printer. So the operating system should be set up for it. And we can see right here it says PRTQ on the end here. I think that's our printer. But I'm not entirely sure if we need to type PRT0 or PRTQ, so we'll try it here. We'll do LST, and this is going to essentially send an ASCII file out to whatever device we tell it to. And the ASCII file we want to send is girl82 here. We got to print our not safe for work calendar. That's how we just have to do it. That's on disk 1, and let's go to PRTQ. We'll do exactly what it says up there. Let's hit enter. Spooler not running. All right, let's try again. Let's go LST girl82 on 1 to PRT0. Let's try that. I mean, this is doing something, but the printer is not doing anything. That that makes me think that potentially I've got something wired up incorrectly, or the speed is set differently. The printer may be set up, I've got the printer set for 9600 baud here, but I have no idea what the Centurion is going to be sending at. Okay, this is going to take a little more thinking. Okay, I've confirmed that the printer is indeed working because I can still send it my test prints from the laptop over TerraTerm. So I'm just having trouble getting this to talk to the printer, which is not unexpected. I think it might have to do with line feeds. I think when the Centurion sends a line feed, it just sends a carriage return, not a carriage return and a line feed. And this has a dip switch setting on it to do automatic line feeds or not. And so let's see here. Let's try again. Let's do LST girl 82 on 1 PRT 0. Fingers crossed. That was not it. It's always cabling. It's always a cabling issue. The printer is fine. The computer is fine. The trick is trying to get the two connected to each other in a way that makes sense. The problem was that I didn't have the rest of the handshaking stuff squared away. So I've got pin 6, pin 8, and pin 20 all connected to each other on the printer side, which should be DTR, DSR, and DCD, I think. So let's give this a try. We'll do LST dump on 1 and PRT 0. This is just a really small JCL program that should print out a couple of lines just to see if it's working. Yes! Oh my gosh. It may seem like I'm overly excited about that, but that took like 3.5 hours to figure out. It's not all sunshine and roses though. If I print the dump file again, I've got it keyed up here. So if I hit it, it seems to print totally fine. Sounds fantastic. Prints nice and quick. The problem is that it shouldn't be done printing yet. The dump JCL file is actually quite long, and it only prints a small portion of it. And initially I thought this was because maybe we were overrunning the buffer at 9600 baud, but I hooked up flow control. I actually got flow control working. Took me like 2 hours, but I got flow control fully working between the two, and still, same problem. Wait, cut, wait, whatever filmmaking term you want to put in. Everything you just watched was filmed on like Thursday, and it's now Saturday, and things have changed. Most notably, every Friday night at about 9:30 Central Time in the US, I try to do a little online chat with everybody over on my Discord. I hop on at 9:30 and we talk about and swap stories and trade and share interesting things that we found, but also sometimes we come out here to the office and we get to work on something together using a massive group effort to get something going, and that's exactly what happened last night. We fired up the TI-810 printer here, we fired up the CPU5 Centurion, and we got down to work, and it took us like 3 hours, but check this out. If I go ahead and hit enter on the incantation I've got keyed up here, it starts printing just fine. This is the Girl 82 calendar, and it's gonna print that entire thing perfectly. So what happened? Well, it was a cabling thing, and it was a handshaking thing. The RTS and CTS lines do not exist on the printer. I knew that. And so I was using the DSR and DTR lines to essentially perform handshaking with the Centurion. But it turns out that it just uses DSR, DTR, and DCD, and that's just to bring the printer online. That's not actual handshaking. That's not actual information from the printer telling the computer to hang on, slow down, my buffer is full, I need to wait for it to finish. That type of communication is done over pin 11, which makes no sense whatsoever to me. Pin 11 doesn't equate to anything on the RS-232 list. It's just TI decided to use pin 11. As soon as we figured that out, and all credit goes to Ken Romaine and Avery on this one. They were absolute legends in the chat last night, and they figured it out. Once we got pin 11 wired up, handshaking is now working perfectly between the two, and the printer is printing at 100%. It's absolutely fantastic. There we are, full print, absolutely perfect. This finished exactly like it was supposed to. So that printer is working at 100%. The CPU5 Centurion is talking to it at 100%, and this is now a complete combination. So I want to thank you all so much for watching, and I hope to see you in the next episode.